Hi, my name is Bill Mungin. I'd like to introduce you today to the power-up demonstration. Today we're going to be testing lubricants, or hydraulic lubricant. This is a John Deere oil out on our tester. Now this tester puts out 200,000 psi. This tester used to have an arm or a lever. It would put out between 7 and 10,000 psi. But let's move to the power-up demonstration. We're going to take a Timken bearing that's locked on a holder and put it against a Timken copper erase with no lubrication. Now these are 1 pound weights I'm hanging out on the end of the spectrum here. And with 2 weights, no lubrication, the bearing is getting started up and the tester stops. So to start out with, let's take a look at our scarred mark with no lubrication at all. Now we're going to snap a reservoir on the tester and add the John Deere hydraulic oil into the application. Now we turn our bearing to a new location. We're right back on here now. Take our weights off. And put them back on. Now, keep in mind that second weight, you can hear it's helping the lubricant out a little bit. When we put that third weight on, it's stopping. Now, I'd like to show you actually what took place on that scarred mark on the bearing surface with the third weight. If you look real close, you see the lines running through the scarring mark. They're identical. We're going to talk about that a little bit later. Okay, the next thing we're going to do is add power-up NNL 690G to the lubricant. It's nice to know we have a universal fortifier that can work with the hydraulic lubricants and drop the temperatures. In most cases, hydraulics are running very hot today. Many times you see them running 220 to 240 degrees, and we're seeing drops sometimes all the way down to 165, 170 degrees. So we're going to take one weight off here. We know we want to keep it running. And then we're going to add the bearings, the lubrication of the power-up to the lubricant. Now, you can see that it's quieting that bearing down. And here's where it gets unique. We're going to put 2 more weights on here on this hydraulic application, and we've just doubled the life expectancy of the wear factors. We're going to put a couple more weights on here. And I think you can kind of see what we're doing for lubrication and how we can work with synthetic oils, organic oils, doesn't make any difference, and increase the film strength of it. Okay, the next thing we're going to do now is I'd like to have you take a look at that scarred bearing mark. Now if you take a close look at the scarring mark, it used to look like this one over here, with the lines running through it. You'll see it's actually starting to polish those scarred marks. So just think about it. We went from a bad situation to a very unique situation of polishing and protecting those wear surfaces. Okay, now we're going to take and turn it to a different wear location. We're going to snap our reservoir off to establish a couple things about the power-up NNL 690G product and why it can work with hydraulic oils the way it does. So what we're going to do first of all is start with a new bearing location. We're going to add power-up on the railing now and put some of it right onto the bearing surface. Go back on again to establish the most important thing about the power-up, working with the hydraulic lubricants. Now here's where we have 3 weights it stopped before. So what we want to do right now at this point is look and see how the application would look, or how much less wear we'll have with the hydraulic lubricants with power-up treating them. Here's our new wear mark, which you can barely see. And you see here's the other scarring marks that we had originally. So now you can kind of understand how unique this product truly is. Now we're going to go back on the wear surface and add some more weights. to establish the most important thing about this product is that power-up does not bond onto the metal surface. Now we're putting about 200,000 psi of weights on here right now at this time. And you'll see the scarring mark with about 200,000 pounds of pressure and how much wear is there. Hardly noticeable. Now in closing, what we're going to do today is we're going to rub the power-up off the bearing surface, and we're going to rub it off of here to establish the most important thing, that it doesn't bond to the metal surface. Because when we take it off, it goes right back to wearing out again. So now we know that power-up doesn't bond onto that application. What we're going to do is take the power-up, go back on it again, and it establishes, it went right back to running, it establishes that, see, this product doesn't bond on. Right back to protecting the application again.